Hello and welcome. In this video, we will understand what is IEnumerable and what is IEnumerator, and we will also try to understand what is the difference between these two interfaces. Let's first try to understand what is IEnumerable. This is an interface that provides a method to retrieve an enumerator for a collection. So basically, this will tell the compiler how we can iterate a collection in C#. Any class that implements IEnumerable interface can be used with the foreach loop. Let me show you in Visual Studio. So I have this array of numbers, right, from 1 to 20. And what I can do, I can use a foreach loop. So basically, I can traverse through 1 to 20 using a foreach loop. That is possible because the array class is implementing IEnumerable interface. Let me show you. Numbers.getEnumerator. So this is basically the method that will allow us to use for each loop. If I go to the array class here, you can notice it is implementing IList interface. And when I go to IList interface, you can notice it is implementing ICollection and IEnumerable. So this is that interface that will allow us to use for each loop and iterate through the list of collection. And we can go to IEnumerable interface also. And here you can see we have the IEnumerator interface. So basically this is the method which will do the magic and allow us to use for each loop. Let's go back to slides. And the word enumeration comes from the Latin word enumerare, meaning to count off or iterating through a collection of items. That's what we are doing when we are using the for each loop. We are iterating through all the collection of items, meaning we are traversing through the list of collection. Enumerate means to count or list things one by one. That's why we call it IEnumerable interface. IEnumerable tells C# compiler how to iterate collection of items. So let's go back to our demo class. Let's remove this piece of code and let's try to find some even numbers from this numbers array. For that, I can use numbers.where and I can specify the condition number such that number modulus 2 equal to 0. And if I hover over on where, you can notice it returns an IEnumerable of integer type. I can store this result in IEnumerable of integer like this, right? And after that, I can use a for each loop. And when we run the program, you will notice we are getting the even numbers here. You can see here where we'll return an IEnumerable, and we will use that IEnumerable to iterate through the collection of even numbers. Now let's understand some of the basic points about enumerator. An enumerator in the most simplistic terms is an read-only, forward-only cursor over a sequence or a collection in C#. So what IEnumerator will do, right? It will provide a read-only, forward-only cursor, and using that cursor, we can traverse through a collection. You can see that happening in this example. Here we have list of numbers. On that list of numbers, we have invoked get enumerator. And once we have received that enumerator, we can use while loop and traverse through each number using the dot current property. Let me show you this in Visual Studio. So let's get the enumerator from the numbers list. So we can invoke get enumerator. So I have created this number collection variable and I'm storing the enumerator which I have received from this method. Now what we need to do? If you try to use a for each loop, you can read the error message here. For each statement cannot operate on variable of type IEnumerator because IEnumerator does not contain a public instance or extension definition for get enumerator. So we cannot use for each loop on IEnumerator. So this is the one difference between IEnumerable and IEnumerator. We cannot use for each loop with IEnumerator. We have to use a while loop. In the while loop, we need to use the move next method. Okay. So if we have an item available, move next will return true, else it will return false. Okay. And once that is done, we can print that number using the current property of the number collection. If I run my program, you can see I'm able to traverse through 1 to 20, but this time I'm using an IEnumerator instead of IEnumerable. So this is the syntax which we have to use. And guys, one more thing I want to make it very clear. When we are using IEnumerable, right? IEnumerable at the back end will use IEnumerator. So what we can say, IEnumerable is basically a syntactic sugar on top of IEnumerator. Whenever we are using IEnumerable at the back end, it will be calling the IEnumerator and use this syntax at the back end to iterate the numbers or the collection. Now let's see how we can use IEnumerable interface on a custom collection. Let's say I have a class employee. Okay, this is my employee class with one property as name. And what the business logic we have, right? The business logic is a list of employee will be called as an organization. So let's create a class organization. So an organization is nothing but a collection of employees. So let's create a private field here. Let's call it employees. All right. And let's create a constructor, public constructor, that will expect a list of employees from the user, and whatever employee list we'll get, we will set it to our private field. Okay, very simple. Now let's use these two classes in our main method. Let's create a list of employees. So I have created this list of employees and I have added 4 employees here. Now let's create an object of organization. And let me pass employees here. Okay, so our organization object is also ready. Now what I want to do, I want to iterate through each employees which are present in my organization. So what I want to do, I want to write this syntax for each employee present in organization, because an organization is nothing but a collection of employees, right? That's what we can say. But if you notice here, right, we are getting the compilation error. That is again because organization is not having any get enumerator method. Basically, organization is not implementing IEnumerable interface. If a class is not implementing IEnumerable interface, that class cannot be used with a for each loop. Okay, to make our class compatible with for each loop, we need to implement IEnumerable interface, and basically this time we want to use it with employee collection. So I need to specify the type here in the angular brackets. Okay, once that is done, we need to implement this interface, and this interface basically will have 2 methods. On this one, what we can do, we can just simply call our get enumerator. So this implementation is done, and for this one, what we can do, we can put a for each loop and yield return employee. So basically what we have done, right, we have told C# compiler what we need to do when we are using for each loop on organization class. Whenever we'll use for each loop on organization class, this logic will be implemented and we will return the employee from here. And here we're using a yield keyword, and guys, don't worry, in the future videos we will understand what is a yield keyword. But for now, we can just assume yield keyword will return the employee from this for each loop. Once that is done, right, you will notice we are no longer getting the compilation error here. Now it all looks fine. Now we can just simply use our console write line and print the name of employee like this. After implementing IEnumerable interface, there is no compilation error when we are trying to use for each loop on our organization class. Let's run the program, and you can notice we are getting all the employee names here. So guys, this is how you can implement IEnumerable interface in your classes, and you can make your class compatible with for each loop. Now let's remove this piece of code and let's understand the other concept. One of the other difference between IEnumerable and IEnumerator is when we are using IEnumerator, that will remember the location of the cursor, meaning that will remember the position of the cursor. But when we are iterating through IEnumerable, that will not remember the position of the cursor. Let me demonstrate this with an example. See, I have this array of numbers, right, from 1 to 20. Let me add two methods and then I will explain how those two methods will work. I have added these two methods, that is print from 11 to 20. First one is taking IEnumerable, second one is taking IEnumerator. And of course, IEnumerator can be used with while loop. So I have used a while loop here and I'm doing nothing but printing that number from the IEnumerator. Similarly, I've used for each loop in this method and printing that particular number. Okay. Now, what I want to do, I want to iterate through 1 to 10 in this main method, and then I want to move to these methods to print the numbers from 11 to 20. Okay. So now first use the IEnumerator and see what is the behavior. So again, gets the enumerator using the get enumerator method here. So now let's use this enumerator like this. So this is the condition that we have here. If the number is less than or equal to 10, then we are printing that number. Else we are moving. Once we have reached the number 11, then we'll move our execution to this particular method, and now this particular method will be responsible to print that number. Okay, now let's go ahead and run the program, and there will be one strange behavior that I will explain. If you notice here, we have printed from 1 to 10 without any issues, but when we reached number 11, right, so after 10, when we called move next, then the cursor was moved to number 11, and then we invoked this particular method. And what happened here, when we called move next again, right, then the cursor was moved from 11 to 12. That's why if you see this output, you don't see the number 11 because number 11 got skipped because we have called move next here. Then the cursor moved to 11, but we did not print that number and went to this particular method. And this particular method is again moving the cursor to the next position. That's why the number 12 was printed and we skipped the number 11. But the main point to notice here, right, it remembered the location of the cursor. The position of cursor was maintained here. We have printed from 10 and then the remaining numbers was printed here. So the position of the cursor was remembered. That's why we have printed number from 1 to 20 and we have skipped number 11. That I have just explained why that happened. Now let's see how IEnumerable will behave. So let's create an IEnumerable like this. So I am using a typecast. Basically typecast is not required. I can just remove this typecast and implicitly it will convert the numbers array to IEnumerable of integer type. Let's comment out this piece of code because now we'll iterate using the IEnumerable. So I will use the for each loop. So this is my for each loop. Again, the condition is same. I'm saying if number is less than or equal to 10, then print that number, else go to this particular method. This time we'll invoke this particular method and we'll print that number using the for each loop. Let's run the program and see the behavior. This time you can notice we printed from 1 to 10, but when we moved to this particular method, it started from the top position. You can see again we started from 1 and we printed till 20. So what happened in this case, right? We did not maintain the cursor position. So this is the second biggest difference between IEnumerator and IEnumerable. IEnumerator will remember the position of the cursor, while IEnumerable will not remember the position of the cursor, and it will start iterating from the top. That's what happened in this output. Okay guys, that's it for this video. In this video, we have understood what is the difference between IEnumerable and IEnumerator and how we can use IEnumerable interface and make our class compatible with for each loop. That's what we have done with our organization class. We have made our organization class compatible with for each loop by implementing the IEnumerable interface like this.